You may be wondering from our last video how I knew that the sine of pi by 6 was 1/2. I didn't use a calculator to figure it out, and instead I used one of our two special triangles. So this is how you'll be able to calculate trig ratios without a calculator. This also means that the trig ratios I'll be asking you for on a test will always be involving the same angles. So one of the special triangles has interior angles pi by 6 and pi by 3. It's a right angle triangle and it has opposite sides 1, root 3, and 2. Now the other one is an isosceles triangle. Its interior angles, since it's a right angle triangle, have to both be pi by 4. And those are our side lengths, 1, 1, and root 2. Now, for this special triangle on the left here, if you take a look, you can see that the smallest angle, pi by 6, is opposite the smallest side, which has length 1. The largest angle, the right one, the pi by 2, is opposite the largest side, 2. And then your pi by 3, the middle angle, is opposite the middle side, root 3. Okay? Now these two special triangles you will have to memorize, because this is the only way you'll be able to calculate certain trig ratios on your tests. So please take a moment. You might want to write those on your formula sheet that I gave you at the beginning of the course. Now, of course, when I look at these two special triangles, I can instantaneously calculate any trig ratio I like using SOHCAHTOA. So if I want to know what the sine of pi by 6 is, well, I can just take the opposite, which has value 1, over the hypotenuse, which has value 2. If I want to figure out the cosine of, let's say, pi by 3, well, the adjacent to that is 1 over the hypotenuse, which has value 2. And let's say I want to figure out the tan of pi by 3. Well, relative to pi by 3, the opposite has length root 3, and the adjacent has length 1. For our other triangle, we could figure out, let's say, the sine of pi by 4. The opposite to the angle has length 1, and the hypotenuse has length root 2. If we want to find out the cosine of pi by 4, the adjacent has length 1, the hypotenuse has length root 2, and finally the tangent of pi by 4 would be the opposite, which has length 1, over the adjacent, which has length 1. Of course, that's 1. Should probably also mention this is just root 3. Alright? So we can use this simple idea to solve some problems right away without the use of a calculator. So let's imagine that we're a surveyor. So we're standing here and we're trying to figure out the height of an antenna. So there's our antenna. And it has a certain height, h. Assuming we're on level ground, we've got our little surveyor standing right there, and our surveyor is 40 meters away from the base of the antenna. So we can complete that right angle triangle, assuming of course that the antenna is standing straight up, which I think is a fair assumption. And we can then construct a trig ratio to figure this out. Now, this angle here is pi by 6, that angle between the ground and that line that goes from the surveyor up to the top of the antenna. We call that the angle of elevation at times. So if I look at the information given, we have an angle right here, and we have two side lengths. So what would be the trig ratio that would connect those two side lengths to that angle? Relative to that angle, we have the opposite and we have the adjacent. So the tangent, according to SOHCAHTOA, is what we want. The tangent of our angle is going to equal its opposite, which is h, over the adjacent, which is 40. Now the tan of pi by 6, if we look up here at our special triangle that has pi by 6 in it, there it is. The opposite is 1, the adjacent is root 3, so 1 over root 3 is the value of the tan of pi by 6. Now I have a very simple equation to solve. I can just multiply both sides by 40, and we get that 40 over root 3 is equal to h, Or if you want to be very polite about this, we could multiply top and bottom by root 3 and say that 40 root 3 over 3 is equal to h. Okay, so we can write our conclusion. The antenna is 40 root 3 over 3 meters tall. So there we did it without a calculator at all. We just needed to know those special triangles, and we needed to know SOHCAHTOA. Let's try another problem here. So again, we're going to completely solve a triangle. What that means is we're going to find all the angles and also all the side lengths. Now we've been given a little extra piece of information here that talks about the sine of 2 pi by 3 and the cosine of 2 pi by 3. So probably the angle pi by 3 is going to be important. So first of all, let's draw a picture of our triangle ABC. So we have the angle at A is pi by 6, we're told in the problem. And the angle at B here is obtuse, it's 2 pi by 3. Okay, and the length of BC is 2. Well, right away we see we have two interior angles, so we should be able to find the third. So if we take pi minus 2 pi by 3 minus pi by 6, we get, again, we'll take a common denominator. And we're left with pi by 6. So that's the angle there at C. Oh, well, that means we've got an isosceles triangle. So right away, I know that since pi by 6 is opposite a side of length 2, this other pi by 6 is opposite a side of length 2. Let's just write a little note about that so we see where that came from if we review this later. So we have that angle BAC, I should say, and angle BAC is equal to angle ACB. We have that AB is equal to BC. So AB is equal to 2. Okay. So we're almost done. We just need to figure out the length of AC. Well, it would be nice to have a trig ratio that could help us out. And we have talked about the sine law in class. So we can make use of the sine law here. We can say that the sine of the sine of 2 pi by 3 over the length of AC is equal to sine of pi by 6 over 2. Now, we don't know the sine of 2 pi by 3, but we do have this little formula up above that we were given. The sine of 2 pi by 3 is equal to this big expression, and if you look at all the trig ratios there, we do know the sine of pi by 3 and the cosine of pi by 3. So we can make all those changes. So we've got sine of 2 pi by 3 according to that formula is equal to 2 sine pi by 3 cosine pi by 3. And now we can use our special triangles and SOHCAHTOA to figure out all the unknown trig ratios in this example. So the sine of pi by 3 is root 3 over 2. The cosine of pi by 3 is a half. And the sine of pi by 6 is a half. Now before we go too much further, let's simplify that. So if I multiply these three factors in the numerator there, I get just 2 times a half is 1 times root 3 over 2 is root 3 over 2. Now I can cross multiply here. I'm going to bring that up there and that up there, since we've got a nice rational equation, and we end up with 2 times root 3 over 2 is root 3, and then we have a half AC. And I just need to multiply both sides by 2 to figure out AC. And there we have it. We've figured out AC and we've completely solved our triangle. Thank you.